As we learned in the last video, there are many different types of monomers that can be chemically bound together to create polymers. There is a specific type of polymer that you need to know about in the AHL curriculum, called a condensation polymer. Condensation polymers are built from condensation reactions, which is when the functional groups of two monomers react to create a new covalent bond by releasing a small molecule, like water. In the case of water being created during this process, the functional groups would need to have the proper atoms present to do so, meaning one functional group would need a hydrogen and the other a hydroxide. After the chemical change takes place, the water molecule is created and removed from the system, leaving a covalent bond attaching the new polymer. These condensation reactions that make water are the driving reactions that produce macromolecules in living organisms, like starches, cellulose, proteins, and lipids. Other compounds that are not associated with living materials can also be created via condensation reactions, like with the production of nylon fibers. The creation of other molecules like hydrochloric acid and ammonia also count as substances made from functional groups of condensation polymers. Monomers can link together to form polymers via condensation reactions that form different types of bonds. If monomers contain two of the same functional groups on either end, they will need to attach to a different monomer that has different functional groups that allow for a reaction to take place. We can see this in the creation of polymers called polyesters and polyamides. A polyester is created via the condensation of dicarboxylic acid monomers, which contain carboxyl groups on both ends, with functional alcohol monomers, which contain hydroxyl groups on both ends. They condense to form water and are left with a carbon to oxygen ester bond, hence the polyester name. One example is terylene, which is a polymer made up of ethylene glycol and terephthalic acid, connected by an ester bond which can repeat many times. A polyamide is created via the condensation of dicarboxylic acid monomers, which again contain carboxyl groups on both ends, with diamine monomers, which contain amine groups on both ends. They condense to form water and are left with carbon to nitrogen amide bonds holding them together. Nylon, as we saw on the previous slide, is an example of a polyamide. In either case, both polyesters and polyamides repeat in an AB-AB pattern because each molecule contains either both of the carboxyl groups or both of the hydroxyl or amine groups, respectively. Some monomers can contain different functional groups on each end, like an amino acid, which allows them to connect directly to other amino acids, in which case the pattern would be AAAA, as all of the molecules are the same type. Long chains of amino acids like this create proteins.